this video, we're going to look at two examples on how to calculate the slope of a line when we are given 2 points. So you can follow along with me in your textbook. This is on page 187, and we're going to do S12 and S15. So first of all, let's take a look at S12. We're asked to find the slope of a line that passes through the point 5, 2 and 6, 9. So I want you to notice before we actually calculate the value of the slope, what that slope looks like graphically. So what I have down here is I have a graph of the line that actually passes through that point 5, 2. So that's this point right here, and the point 6, 9. So this red line is the line that we want to find the slope of. So notice that this line is actually pretty steep. And also notice that this line is an increasing function. So that tells us something about the slope. The fact that we have a line that's increasing tells us that we're looking for a slope that's going to be positive. Okay? So again, that's just something to keep in the back of your mind. Now let's actually calculate the actual steepness of this line. So recall that the formula for calculating the slope between 2 points is the same formula that we used in chapter 1 to calculate the average rate of change. And that formula is y sub 2 minus y sub 1 divided by x sub 2 comma, x sub 1, where x sub 1 comma y sub 1 is a point on the line, and x sub 2 comma y sub 2 is another point on the same line. So what I like to do before I actually start substituting things into this formula is I like to label my points. So if I call this 5x sub 1, then that means this 2 is y sub 1. Then that means that this point here, we'll call that x sub 2, and if that's x sub 2, we'll make the 9y sub 2. So then now it's just a matter of substituting in these values into the formula for calculating the slope. So that's 2 minus, well, let me follow my formula here. So 9 minus 2 divided by 6 minus 5. So on the numerator we get 7, on the denominator we get 1, and that gives us a slope of 7, telling us that the steepness of this line is 7/1, or 7. So in this particular problem, we can also check the slope graphically. So here we found that the slope is not just 7, but remember it's positive 7. And we can again check it graphically. So notice to go from this point down here to this point up here, we move over 1 unit to the right, so that's the 1. And then we moved up 7 units, 1, 2, 3, 4, 5, 6, 7. So up means positive, and then notice that the rise is 7, so 7/1 equals 7. So our graph here confirms what we did mathematically there. Okay, so let's take a look at another example. Okay, here's S15, and we're asked to do the same thing. Calculate the slope of a line that passes through these 2 points here. And again, if we plot these 2 points at negative 3.6, that's around right here, go up 2.5, that's this point right there. And then the point 2.4, so that's approximately right there, and then go down negative 1.6, so that's about right here. Okay, so notice that the line that passes through these 2 points, this line is actually decreasing, so it's falling from left to right. So the fact that it's decreasing, that also gives us some information about the slope. It tells us that the slope must be negative because my function is decreasing. So again, let's actually calculate that slope by using the formula for calculating slope and see what we get, keeping in mind that we know it's going to be a negative number. So once again, I'm going to label my points. I'm going to call this x sub 1, so then that's y sub 1, and I'll call this x sub 2, making this y sub 2. And now it's just a matter of pure substitution. So that gives me negative 1.6 minus 2.5 divided by 2.4 minus negative 3.6. Okay, so on the top here, my numerator, I get negative 4.1, and then a minus and a negative, that gives us a positive, so 2.4 plus 3.6 gives us 6. Right, and then you can simplify this, so that simplifies down to negative 0.683. Okay? All right, so this tells us that our slope is negative and our function is decreasing by 0.683 on the y every time x goes up by 1.